um, the the line which is saturated in energy on the liquid side, the line which is saturated in terms of gaseous on the vapor side. So as I mentioned in the previous slide here, maybe I can show you here that the right hand side is the gaseous phase about to change into totally superheated region. But now on the dry line, the points on the dry line, they are actually boiling points. The point on the liquid line, they are also the boiling point, but the liquid is still in the liquid form. But the right hand side, the right line is the whole liquid has been vaporized at the same temperature. Then if we keep supplying heat further, then what will happen, that heat will be used to increase the temperature, which is superheated vapors. And also here, as I mentioned, the enthalpy, it is equal to U plus PV, where P is the pressure and V is the volume. And now if I go back here, this is how you will calculate in the liquid vapor mixture. You have to understand how to draw the vapor dome, even if it is a TV diagram or a PV diagram. The P is on the y-axis, V is on the x-axis, T is on the y-axis, V on the x-axis. It looks like a same like vapor dome. We call it as a vapor dome. And for water or any pure substance, it looks like this dome. So, and then for the constant pressure line, it is a constant pressure line. Pressure is constant on the TV diagram. This is TV diagram. And similarly, this is the latent heat. Whatever we supply here, it is used to change the phase from liquid to gaseous phase. And on the PV diagram, the constant temperature lines are like this. This is all constant temperature lines. And the V sub G, all the G's, sub G's means the saturated vapor line. The next important thing is, what is quality? Quality, as I explained earlier, it is the amount of gaseous vapors in the whole container, in terms of like how much liquid vapor mixture. There is no quality inside the superheated region or inside the compressed liquid region. Only the quality will lie inside the liquid vapor mixture. So if I tell you, okay guys, what is x equals to 0.7, this means that in a whole container, 70% is vapor and 30% is liquid. And the marking will be near the dry saturation line because it is close to the gaseous phase. Let's solve this problem. In this problem, a rigid tank contains 10 kg of water at 90 Celsius. If 8 kg of water is in the liquid form and the rest is in the vapor form, determine the pressure in the tank and the volume of the tank. So let's go ahead and find out some unknowns. So volume is constant. A rigid stands for the constant volume. And now in this constant volume, which is the mass is it is water. The mass of water is 10 kilograms, and mass of the fluid, it is just liquid, which is 8 kilograms. Water is in the liquid form. Determine the pressure of the tank. So how would you determine the pressure? So what you have to do, first of all you will find out what is the quality of this water. So mass of the gaseous phase, which is 2 kilograms, 10 minus 8 is 2, divided by the total mass, which is 10, so it is 0.2. So 0.2 means 20% of the liquid has been vaporized. And now you will go to the charts. Here there are table A-4 in your book. So if you open your book, let me see if I can show you the book here. So in this book you will see the tables. So you have to find out the water table A-4, and in this table, since the question is stating that you have to find out what is the 90 degrees Celsius at 90 degrees Celsius. Oh, so what you have to do, you have to go to the your book and see at 90 draw. I would always draw the rectangle. So let me show you what I can show you here. So this is my 90 degree. Okay, so if I draw this rectangle around here to show you that this is what of my interest. So let me go back. So maybe you have understood the idea that how to find out the specific point in the table. So let me go up here. Yeah, so we just have to look into the temperature table. There are different types of tables at the end of the book, and this is known as the temperature table. So because we are given with the temperature only, so we will look at 90 Celsius. At 90 Celsius we will draw a rectangle or underline this line, because all these values are like if you take a picture at this temperature, what is the saturated liquid value, the volume of the saturated vapor, and the saturated liquid value, internal energy. This is all internal energy, this is enthalpy, and this is entropy. So you can find out many things in that table, like specific volume, number one, property number two is the internal energy, number three is the enthalpy, number four is the entropy. But in this chapter we will be focusing more on the first three things: specific volume, internal energy, and enthalpy. So now let me show you over here. So what I'm gonna do here, I will find out the peak saturation temperature, which is 70.183 kilopascal, as it is mentioned here, 70.183. And then there is a formula how to find out the volume of the, remember the quality means that this is a liquid vapor mixture. 0.2 is the point near the liquid line, which is x equals to 0.2. And then you have to find out using this formula. If you want to find out the total volume of the container, and then you will use this formula. Vf stands for the volume at this line. This is V, this is Vf, this is Vg, and then Vfg stands for Vg minus Vf, the difference between the gaseous vapor and the liquid line. So then you will multiply by x and times Vfg, and then here you get this volume. Once you get the volume, specific volume, as you know, it is equal to volume per unit mass, and the volume equals to specific volumes times 10, total mass 4.73. so this is your answer. The question is asked, find out the pressure. We already found the pressure using the table, which is 70. So this is our answer number A, and this is our answer number B.